So now we're ready to go make our revision changes. And we can come in here, and most of our revision changes are going to be set from op2. We are going to add in op1 the grooves. So let's go ahead and start with those grooves. Now, for internal grooves such as this, we're going to use simple contours. I'm going to do one thing before I get started there is I'm going to measure what these grooves are, or look at the print. In this case, we're going to go ahead and measure it and just see what cutter we're going to be using. So it is a 197 width. So I'm going to copy that, and just for speed I'm going to go ahead and use a 197 width tool. So I'll come into my cam, we're going to use a 2D contour. Now you'll notice things are backwards here. Well, what that is this is actually on the default folder, which is set to op2. So let's go ahead and click op1, and we can hit Shift D, not Control D. Control D is duplicate. Shift D is the shortcut to actually create and make the default folder. So we've got Shift D and Control D. Now that's important to remember. Now that that little check mark's up by that folder, this is our default folder. Let's go ahead and do contour once again. We're going to go into our tool library. We're going to make a new mill tool. First go to cutter, and we're going to create a slot style cutter. So we've got our slot mill. Now the default for this is it's just plain ridiculous. There's no way around it, but it forces you to actually create the diameter of the tool properly. So what I'm going to go ahead and do is create a 750 tool with no corner radiuses, with the flute length pasted from the information that I took. We're going to go ahead and the same for the shoulder length. And now for the shaft diameter, we'll go ahead and do 3/8. And that's going to be the simplest, fastest way to define our slot mill cutter. Now, we would normally look for a normal size on this cutter and do multiple depths, but what I'm going to do is just go straight at this with our custom slot cutter. So now it's time to select those contours. Now this is where I was saying that as you can see, the geometry shows up on its own as full geometry still. It knows the model is full, so I've selected that geometry. That's really all I need to do. Now I'm using 2D contour for this, and this is where I'm going to show the difference. So 2D contour is okay to use. It will lead in where I want it to lead in, and machine the arcs just fine. But another way to go about this is to actually use the 2D milling circular tool once again. Now the significant difference is that the circular tool is going to have a little intelligence built into it, and it knows where the top and the bottom of the hole is based off of these heights that are automatic. And that's more or less what we want to do. The other option is within circular, we have the option to lead in, lead out to the center of the hole. Now a lot of times I like to do that just for sake of true positioning and knowing where the position of that is going to be. So I'm gonna keep this one, and I'm gonna delete that 2D contour. But you can use either one. The other side to the circular is that the posted code is going to force arc moves versus anything you may have set up within your post processor for odd contoured surfaces. So now that we've added that, we do want to have spot faces on the back side of this, and then this is kind of unorthodox, but I would rather switch between the two operations here and do that. So I'm going to take the old spot and I'm going to put it up here in op1. We're going to change that. We're going to grab the geometry of the holes once again. It's going to grab the entire selection of those holes based on the same diameter selection. And now the new op1 is set, and that is using the actual revisioned part throughout the entire process.